Hey guys, here's the video that I promised you. It was good seeing all of you in the chat the other day. Yeah, I really like you guys, and I don't like anybody. So here's some problems that you could go by. These two sections in the book are really easy. They're sections that look really hard, but they're unbelievably easy. If you just follow the formulas and you just go step by step. So first one I'm going to do is 8C, and the reason I'm doing 8C is because A and B just ask you what the angles are really. So we're going to get right down to solving it and what it looks like. And always rely on the yellow boxes, particularly this one because it has everything in it. But if you see this, and you have to match this up with what formula it is, and it's good if you have your book with you. If you don't have your book with you right now, pause the video and go get it. Look at page 664 on the bottom, the yellow box, and you see that the second formula there matches up with this. It's two cosines added with two sines of two different angles, and you can convert that to this. Use a simple common denominator to reduce the angle to pi over 6, and you have 3 over 2, square root of 3 over 2 for your answer. If you look at number 32, which is similar, it's a bigger, uglier formula. Look on page 668, and you can match that formula up with the first one that's there, and this reduces down to that. So you're going to have to take a look at this and see what happens. If you add these together, they already have a common denominator. It comes out to be pi, and the tangent of pi is 0 over -1, which is just 0. So if you look at number 14 on page 680, which is section 3, it's the same thing. It's just a separate set of formulas, and these we're going to use the box on page 697. Now those boxes are cumulative. They keep collecting all of them for you, so you don't have to go to different places in the book to get those identities. This one, though, they're telling us that the sign is -2 over 3, and it's in quadrant 2. Now, if you had this course before, or if you look in some of the examples, what the book will do is they'll divide everything by a 3 to make this inside the unit circle. I don't do it that way because you're dealing with more fractions. If you reduced everything by 3, you would get a 1 on the radius and you'd get your unit circle. But I think it's easier to do it this way because I know a lot of people don't like fractions. So I'm looking on here, and they're asking me what is the sine of twice this angle. If the sine of the angle is -2/3, they're saying what if we doubled the angle? What would the answer to the sine of that be? And what I would do is make the triangle in the third quadrant, use the Pythagorean theorem, take a good look at this, what's happening, to find the missing side. But it's going to be a -√5 because it's on this side of the x-axis, on this side of the y-axis, really. So what we're going to do is just write the formula down, since we know that the sine of the angle is -2/3, and cosine then would be the adjacent, -√5 over 3. And then just do your arithmetic to get your answer. Cosine of 2 theta is the same thing, only we use a different formula. Now there's a few formulas for this. I just chose one of them. I chose the one that looked the easiest. And since I knew what sine was already, I just chose this formula, and you collect that up. It's a second formula on page 679, and look through this. The last one, they're saying what would the tangent of double that angle be, and I'd have to use the tangent formula in that same box, and then just write it out, and then solve it. And you can take a look through this. Just be careful with your fractions down here in the square roots. I also thought we would do something like this. Now, this is a half-angle formula. So if it's a half-angle formula, I need to use those half-angle formulas, which are also in that yellow box. The thing is, again, they have a missing side, so you just use the Pythagorean theorem to find out that missing side, the hypotenuse, comes out to be 25. I decided to use this. I didn't use this formula because I thought the other two forms might be easier. Maybe not. It's inside a square root, but so if you did this formula and plugged in, check it out, the sine is 7 over the 25. The 25 would be up here, right? because we just solved for it and we found out the hypotenuse was 25. And then we just plug the numbers in. But remember, when you divide by a fraction, you flip it over and multiply. The 25s cancel out, you get 1/7. I also showed you the other formula, which is the same thing. It comes out to 7/49, which reduces to 1/7. So it's the same thing there. What I want to mention to you before we go is that here are the quizzes, the dates for the quizzes. We may end a little early, so we might not need this one, or we might push this one up to this date. Because believe it or not, we are ahead of schedule. We're actually not doing as many problems as we would do if we were in class, but you're getting the gist of everything. And if you try these homework problems, it seems like a lot, but they're the odd ones. Check your answers in the back as you go. And don't give up real easy if you don't get it. But rely on that box on page 679. You're going to need that page 679 box to just transfer what they're giving you into one of those formulas. And try these problems and let me know if you have any difficulties. Send me an email. Have a great night. I'll talk to you soon. We'll have a quiz on this stuff, these two sections, 2 and 3 of Chapter 5, on Monday. What class are you? 2 o'clock. Have a good night. Bye-bye.